So good morning, everyone, and thank you for joining this webinar that we call the Data Factory series here at AI Innovation of Sweden. And the purpose of these seminars that we will do the coming week is for the Federated Learning project that we recently started. And we have invited some of our partners to do presentations on the work they have done so far on Federated Learning or Decentralized AI, or call it swarm learning, if you will. We have seen a big interest in this topic, and therefore we wanted to provide these series for all the partners, also the ones who are not specifically involved in the Federated Learning project. And we are also going to do 2 more webinars on this topic together with Swiss Data Science Center and another one from Google, and they will both be on the 25th of June. So you will receive an invitation for that webinar shortly, but please note in your calendar on the 25th of June. It's going to be in the morning. And today we have the pleasure of having Hewlett Packard presenting their work on swarm learning. And I will shortly introduce our presenters and the attendees from HPE. But before that, I just want to mention that this webinar is being recorded, and that if you have any questions throughout the webinar, please feel free to use the Q&A tab at the bottom of your screen and type in questions. And then we'll also have a Q&A session at the end of the webinar, so around 11 o'clock, and there we'll take all the questions. But if you have something that is urgent and that you need to ask throughout the webinar, of course, we can do a short little break in the presentation. Otherwise, we'll do all the questions at the end. And before we go on with the presentation, I also have here with me Mats Nordlund, and maybe I should say that my name is Ebba Josefsson Lindqvist. I'm a project manager of the Data Factory, and Mats Nordlund is our board sponsor for the Data Factory. And you have some messages from Vinnova.
Yes.
And I will also just share the screen, but please, Mats, go ahead.
Yes, it's great to see you all here. And I wanted to share with you some information that I received from our colleagues at Vinnova. Vinnova is the main sponsor for us here at AI Innovation of Sweden. And I want to draw your attention to 3 calls that are open right now. And these are calls where you can apply for funding to explore and learn and experiment with some of the things we will talk about today. The first call that's open now is called Decentralized AI Systems. And this is a call where you can apply for projects in exactly what we will hear about today. So in Edge AI, Federated Learning, Swarm Learning, Mesh Learning, or similar. And the requirement here is to be 2 companies in collaboration in this kind of course. The amount you can apply for is up to about 500,000 SEK. Then we have the next call that's also open is called Start Your AI Journey. There are 2 portions of that, or 2 parts. One is for public sector actors. So that would include cities, regions, hospitals, and so forth. And you can apply for a first smaller machine learning or AI project to learn or to evaluate the potential of AI for what you do. And there you can use data you have and see how would that work. It's also open for businesses, for the private sector, and it's the same intention. So it's a first step, learn about AI and how it could help you in your business. And here it's the amount you can apply for is also 500,000 SEK. You can learn more about everything we see here at the Vinnova website, which is vinnova.se, which is also at the bottom right corner of this here. The last call that's open is that's relevant for today. Of course, there are many more calls there, but directly AI related is this one here called AI in the Service of Climate. And here you can apply for funding to take ideas that are emerging from research and bring them into maturity and integrate them into decision support tools. So this is not for fundamental research, but it's the next step, let's say, beyond fundamental research. And the funding levels here are higher, and the projects are expected to be longer. So with that introduction of ways forward if you get inspired by this presentation from HPE. I'll pass it back to Ebba so that she can introduce our main speaker of today.
Thank you very much, Mats. And let me just stop sharing the screen real quick. There we go. And with us today, we have Krishna Prasad Shastri, who is Chief Technologist at Advanced Development Center of Hewlett Packard Enterprise. And Krishna Prasad Shastri is Chief Technologist for India Advanced Development Center. Prasad is responsible for driving strategic programs and advanced development in emerging technologies like artificial intelligence, machine learning, edge computing, and blockchain. In the past 6 years at India ADC, Prasad has led several research and advanced development activities in the areas of big data, in-storage computing, software accelerators, and memory-driven computing. Currently, Prasad is focused on developing solutions for decentralized AI and machine learning in cycle management. And I will give the word to you in just a second, Prasad, but first we will also introduce Peter Werdenhoff from the Swedish part of HPE. So welcome to you both, and Prasad will do the presentation from HPE, but then we'll bring Peter back in for the Q&A session. So good morning, Prasad. How are you today?
Good morning. Thanks for having us. Doing good. Hope you all can hear me well. I'll just go off the video mode just to ensure we get a sufficient bandwidth.
Thank you very much. And also feel free to start and share your presentation. And we will turn off our camera from this side too. And remember, you can always ask questions in the Q&A tab and we will monitor. So thank you, Prasad, and feel free to start.
Thanks. Hope you all can see my screen well. Okay.
Yes, we can. Thank you.
Okay, great. So let's get started on as Ebba and Mats mentioned in terms of the overview. So I want to structure my presentation predominantly to spend some initial minutes talking about the machine learning, where we are with respect to that today, what are the challenges we are facing, then discuss about the solution, swarm learning, and then I will spend some time talking about some of the use cases which we are working on, and then at the last, spend some time trying to show you how to convert your existing models into a swarm models and put it into a deployment kind of a thing. As I said, so feel free to send the questions in a chat, or if you want to interrupt, so please let me know kind of a thing to take any urgent questions. So with that, without wasting much time, so let's just start with the AI. And then as many of you would know, this is not something new. So we have been working on this for past 30, 40 years. There's this very well-known kind of a thing, it's called as rules. And we call it as a models, which is built with a set of rules, which is well-defined. Okay? And then you pass the current condition into that rule, and then it will do a good prediction. And we have been using this in pretty much every verticals. So it could be in a financial, credit card, fraud detection kind of a thing. We look at into the medical field with clinical decision support systems, etc. Recently, a decade ago, kind of a thing, the data scientists who started asking, so provide your experimental data, and we will help kind of building a model. So what they asked is to provide a significant amount of the past data or a historic data as an examples. And then they used that example to look at what is the outcome and started developing a model. It means you're developing a set of adjustable dials. And they trained the dials by doing tens, hundreds, thousands, millions of these examples, and towards end of that, they got these dials adjusted such that when they passed the current condition, it could do a very good job in terms of doing the prediction. Of course, I'm simplifying a lot because I just want conceptually to understand what does it mean. It's basically you pass the historic data, make the model to learn to adjust the dials. In the neural network world, if we talk about, these are the weights of the neural network, pass the current condition and get the prediction. That's the machine learning. And then the journey, if you look at, the organization started developing these machine learning models using the data they had. It could be depending upon, like, okay, if it's a research organization using their data, or probably it's a business unit using that particular data, or it could be on a geography kind of a thing. They all use the data available to them and then try to develop the model. As we've seen in the previous slide, for the model to reach a good accuracy level, it needs significant amount of data. And having this siloed data, which is not shared across, it kind of hurts the model's accuracy. So then comes the era people started looking at centralized training. So they started moving the data into a center repository. I've just shown it as a cloud. You can think of it an on-premise data center or a cloud. It is a central repository. And then they had all the computational and the storage power there to train the model. So it helps to get a significant amount of data in a one central repository so that we could build a real good models which can be deployed onto the productions in some cases. And then once the models are built, to get a better performance in terms of inferencing that model, or as I said, to find the prediction of the future, depending upon the current condition, these models are taken back and deployed on the edges to do the inferencing so that they can overcome the latency of sending the data to a data center, do the inferencing and get the result back. And this is what we see as a current deployment scenario in most of the cases. I would probably want to say that's how the machine learning is done today in most of the places. Now let's start looking into a set of challenges it brings up. We categorize them into 5 different set of challenges. I'll go one by one. So initially we looked at, we can categorize them into the space of efficiency. Okay. And as you can see, the data is moved from wherever the data is generated into a central repository. And depending upon the scenario in the medical, let's say if it is kind of an X-ray images coming through the medical imaging systems that need to be moved, significant amount of data need to be moved. Let's look at autonomous vehicles. The data which is coming from every moving car is need to be get moved into that. It's a huge amount of data, and moving the data is a significant challenge. It's not challenge only in terms of a bandwidth. It's also a huge challenge in terms of having a centralized storage to store all the data. So we're hearing from some of our customers or the partners that in a moving car on autonomous vehicles, we get around 8 terabytes of data in a given single day for a given car. So now you can imagine like that, okay, if you're running hundreds of thousands of cars over a period, how much of data would come in kind of thing. So it causes challenges in terms of storage. And now to build the model using that, it also needs a significant amount of high-end compute capacity. So it's going to have challenge in all the areas of compute, storage, and the networks. Now, sorry, excuse me. And this movement of data, it's all good if we can get all the data into centralized location, but there are a lot of regulations and the laws which prevents them. An example is a GDPR in the European Union, which prevents movement of a data. Okay, so across the boundaries. So now we get into data sovereignty area challenges, and we cannot have sufficient data. It could also be a data privacy related challenge. So particularly in the field of a healthcare or a medical, if you look into the patient's medical data is very private, and so it may not be possible to move it into a central repository. Okay. There are a lot of challenges in with respect to a data security, data sovereignty related laws, which prevents movement of data into a central repository. And we have seen if we can't have a sufficient data, we're going to have an inferior model accuracy, inferior model. And this restriction on data movement also manifests in terms of another problem, which you could look at as a biased data. Okay. Let's say it could be biased depending upon a demographic or a geography, or it could be biased in all other times. So it's basically, I'm referring this as a non-IID data, which is independent, identical data, but it's not independent data, but it's not identical data kind of thing, right? So just to give an example, let's say if you're building a model to do facial recognition, and depending upon where we have fed the images to do the facial recognition, that model might be able to detect the white skin faces better than the dark skin faces, or a vice versa. That's mainly depending upon where we have fed the data. And then such kind of a biases is not acceptable particularly. So we can't really have a model dealing with those kind of a biases because of the data privacy or data governing kind of some of those rules, regulations to build that model. And let's look at the recent examples, what we are all going through in terms of this pandemic scenario with this COVID-19. There are highly chance like that, okay, no single institute has sufficient amount of data to build a model, because we have very limited amount of data, and then that is also spread across. And it's not owned by one single institution. So it means we need to make or provide a framework for multiple organizations to come together, share the data, collaboratively build the model. So now we talked about the issues with the data privacy laws and the regulations in terms of sharing data. Another key aspect which also prevents that is the value of data. So everybody knows the data is of significant value. It is also called as a new currency. So the owners of the data would look at mechanisms to monetize the data, or how can they incentivize if they need to share the data. So we think the machine learning framework, if they need to enable a collaborative machine learning, it should also have a framework to enable the monetization or incentivization of the participants who bring up and unique data into that. These are the 5 different set of challenges which we classified, and which you can see in most of the scenario where we look for centralized kind of a machine learning. Now looking into that, the researchers and the industry started, what can they do it? And one of the things it basically comes up is a federated learning. So as mentioned earlier, so you are going to probably listen more about this in the later talks. But in a nutshell, the approach is, can we take, instead of bringing all the data into a central repository and training the model, can we take the model to where the data originates, in that case call them as an edge, and then whether the model could be built there. Okay. It's an approach of doing a distributed machine learning, okay, where the models are trained at the edges, and only the parameters, which is weights of a neural network, are shared to merge the parameter values to come up to a global stage of those parameters, which would help to improve the accuracy of the model. In the federated learning, the models are getting trained on the edge, but the parameters are merged by a central coordinator. So all the participant edges train the model, send their model to a central coordinator. The coordinator merges them and then sends back. So if you look at this, one way it solves the problem of the data privacy in terms of not letting the data shared with other parties, or even sending the data into a central location. But still, there are some set of issues we might look at in terms of sharing the parameter with the central coordinator, or what happens in those things. There are various different, the privacy related research which is happening, which is probably looking in the space of multi-party computation kind of a thing, or homomorphic encryption, and a couple of other things which are happening out there. And we, predominantly at HP, we looked at that can we take it from a distributed kind of an approach into completely a decentralized approach? So when we said, let's ensure the edges train the model, and let's also eliminate that central coordinator. So instead of that, the edges themselves can play the role of merging those model parameters. So in this case, as we can clearly see, the data stays at the edge and also the parameter stays at the edge. So the parameter also doesn't go into any single central coordinator. So instead of that, the parameter gets merged in the edge itself. So it again meets the aspect of providing the data privacy, and also it makes it a little bit more one step ahead in terms of not even sharing the parameters into a central coordinator kind of an aspect. And also we have built or provided a mechanism of building a framework to enable monetization. So I'll talk about that a little bit more in detail now. So let's try to see how this whole thing works. Technically, we are showing a 5-node swarm network. Think of it 5 different departments or the 5 different edges. They are coming together to participate in a swarm network. As a very first step, we will build a network, which is a decentralized network, and enroll the participant into that network. We have built this network based on blockchain. I think towards the end of this slide, you would understand why we have used blockchain and how it helps. Okay. The foundation here is the blockchain provides a very robust decentralized network, okay, that we have used, and then we onboard the participants. At the time of onboarding, we do an authentication and identification to ensure only the authorized nodes can participate in the network. Okay. And then as a next step, each of these nodes will they get the model from the central thing at the time of registration, and they train the model using their local data. Okay. And they train that model using local data for an epoch, and which is a tunable parameter. Think of it a time window. Okay. And once all of these nodes train the model for an epoch, they get a parameter. That means they have learned something. If you remember the first slide when I said you pass some inputs and then you start adjusting the dial. So they have adjusted the weights to a certain degree. And I'm just generalizing it as a parameter for ease of understanding. And then all these participants using a blockchain, they try to elect a coordinator. And then they send the parameters to that elected coordinator. The coordinator merges all these parameters and sends back the average parameter to all the individual nodes. The key thing here is we kind of use the smart contract in the blockchain to implement a secure contract which can, in a trustworthy manner, enable election of the leader. Okay. And now we could just look at the nodes will continue the training, and they get the next set, and they elect the next coordinator, pass the parameter, merge, and keep on continuing this process till the model achieves the desired accuracy level. And the election of leader is again a tunable property in the network. So it could be adjusted using some of the parameter for the smart contract. So we could do a round robin, or some of the nodes which finishes their local training first, they can volunteer themselves to do the training. So there are multiple different mechanisms could be implemented. One of the other key questions that comes up is what happens if some bad actor comes into the network and they try to influence the learning in a wrong way. So instead of doing a good merge, they can try to probably influence it in a wrong way and started giving back the wrong parameters back. So to prevent that, again, the entire merge algorithm is implemented as smart contract. So the blockchain smart contract is again a tamper-proof software which cannot be modified by the other participant without the consensus of all the parties involved. And that code gets executed by any of these nodes who get elected as a leader. So we kind of protect that software piece which is doing the merge algorithm by using the smart contract feature in the blockchain network. And now, finally, we use the crypto tokens mechanism provided by the blockchain network. So if you have heard about like the Bitcoin or ETH coins in Ethereum and all those things, they are representation of the coins of the crypto tokens. But we use the framework of using the crypto tokens to build a monetization framework. That means every time the node which trained the local model and contributed the parameters for the merging, at the time they get incentivized with a certain tokens. And then for the given business scenarios, it could be built a business case to convert these crypto tokens into whatever the value we have to see and then implement as an incentive or a monetization framework. So fundamentally, the swarm learning framework has a mechanism of enabling the built-in monetization here. Okay. Now, let's look at how it works in some of the use cases. So let me just take a use case of here, diagnosing or predicting a disease by looking at X-ray images. So we have picked up some of the examples which are available with NIH, that's National Health Institute in the US, the repository, and the data which is available in the open source, so which is available in a Kaggle. And we have also used the machine learning models which are available in a Kaggle to ensure those models and data we can leverage and show how it can work with the swarm learning. So the dataset has a lot of chest X-ray images. I think it has more than 60,000 images of chest X-rays. And it is labeled to identify 14 different types of diseases. For the purpose of this demonstration, I have picked up only 4 different types of diseases. You could look at effusion, which is type of accumulation of fluid in the lungs, or atelectasis, which is partial collapse of the lung. Pneumothorax is a full collapse of the lung, or a mass is kind of a cancerous cells in the lung kind of thing. And we took this data, and to simulate that environment, we have spread that across 3 simulated hospitals in 3 different geographies. Look at a hospital in Chicago or London or Bangalore to represent that. And while doing this distribution, we have induced a bias into the data distribution. And what we can see here is the hospital in Chicago sees less X-ray images of the type pneumothorax and sees the sufficient image for the other types. And similarly, London sees less images for mass, and Bangalore sees less images for atelectasis kind of a thing. And you can look at in the real world, we see a lot more biases and this kind of a thing. For an experiment, we set it up like that. And now we could see what happens if these hospitals are trying to build the models and then trying to predict it. And we tried to measure that to an accuracy, which is F1 score. In the healthcare industry, F1 score is a good measurement for looking at the model's performance. Now, as we can see, the models which are built by these hospitals, they do a fairly good job in identifying the diseases for which they see sufficient amount of X-ray images, but fails to identify a disease for which they see very little images. So which is evident here, like Chicago is failing to identify pneumothorax, and similarly London fails on the mass and Bangalore on atelectasis. Now we have built a swarm model. We have installed the swarm framework and trained this model using the swarm framework. And then now we could see through the swarm framework, the model which is built through that, it helps those hospitals to identify the diseases on which they see a very little images. That means the kind of biases which are there in that model has been eliminated, and they're able to do a good job in identifying that. And now if you look at the other diseases for which they see a good amount of X-ray images, the swarm provides equal or better kind of a performance. So we kind of say it's equal. Sometimes we might also get a better performance, mainly depending upon how the data is distributed and then how many times it's running kind of a thing. So we could very clearly see that swarm is helping in terms of both the data which the individual model sees in a sufficient quality as well as the bias things. So let's just look at how it can manifest. So we have built a mock-up demo, which is something like you can look at like a lab technician. Once the X-ray things are done, once they look into images, he could run them through that and then try to see what happens. So it's a pre-recorded demo video. I'll just play that video. So we select an image. So it's the second image, try to do an inferencing. And we could see the way it's structured is we have just made it as a one single screen to show what happens in the different hospitals. And on the top right side, I'm showing what is the actual diagnosis, which is looking at like the of the image looked at by the technicians, and what result we're getting in a swarm in the right bottom. So in this particular case, we could look at this image, which is a mass type, which is wrongly classified by London. So this is an example, is like that, okay, because it didn't see a sufficient images and it failed to classify the thing properly. So it's an example where we are doing misclassification. Now let's look at another image randomly and then try to see what happens. So we're picking an image from the middle, looking into that inferencing. In this case, we could see Bangalore fails to identify, thinks it's an X-ray image of a healthy person. So it's basically failed to identify things. And then similarly, we'd also support a multi-class classification. It's not just identification of a disease, yes, true or no kind of a thing. It's a single classification. It also supports multi-class classification. And here again, we could see London identified as a potential of a fusion, but failed to identify the mass aspect of it. Okay. Let me also quickly turn into maybe the other set of the things which we are working with our customers and then trying to see how well the swarm works in the real life kind of a thing. So what we are doing in this case is we are taking the transcriptomes, which are basically the transcription of the blood cells into the genome sequence. And we have used various different techniques of those transcriptomes, which I'll just talk in a minute. So the sequence is, you can look at, there are patients who had cases and the controls. Okay. The cases represents patients having a particular type of disease. Control is a representation of a good persons there. It's the person not having that particular disease. And this is done in a various different studies. So for this example, we kind of use the data from several studies. It's hundreds of studies. You could look at the studies as the data set which is being processed by a single laboratory kind of a thing. You can make that as an analogy. And these multiple of these studies are combined into a kind of a node sometime. It's again to represent if there is an hospital chain which is having the similar kind of, or in the same region having multiple studies, and then all of them are combined and then trying to do it. It also indicates we could support completely a mesh kind of a network with the swarm, and also kind of a hierarchical kind of a network kind of concepts. And then on the middle thing, it shows we have again used the 3-node kind of a representation here to represent there are 3 different nodes participating in that. They're having data coming from a different studies, and then finally build a model which would try to do the prediction. And let's look at the results. So what we have done is we have basically taken the nodes which are having specific studies. So for example, let's say a study of ABCD goes into node 1, or the EFGH goes into node 2 kind of a thing. So it's basically the nodes will see the specific studies, and then we have ensured they have a kind of an equal data distribution. So that is the red and blue bars indicate 1:1. That indicates the case and control distribution is equal there. And you also see the total amount of records are also equal in those 3 nodes, indicate 27%, 27%, 26% kind of thing. And we try to validate that with 20% of records on a 4th node indicating the results. So as we could see, and then we have done that with hundreds of permutations. So and then now if you could look at the first graph, it shows the individual nodes does pretty poorly in terms of predicting, and Swarm does fairly well. And then that you can really see it well on the right side chart. It shows Swarm outperforms all the individual nodes. Okay. The point to note here is like, okay, we looked at specific thing here. So now we said, okay, let's see what happens if we have used a different type of a technique. So the blood transcriptome, it has multiple different techniques. So the 2 very well known things are DNA microarray and RNA sequencing. And within DNA microarray, there are multiple kind of the platforms if you really look into doing it. So now what you've done is one of the node is really use one type of a technology. So let's say a DNA microarray technology 1. And the node 2 used a DNA microarray, let's say a technology 2 or a platform 2. And the node 3 has used a RNA sequencing kind of thing. We wanted to see what happens if you are using a different technologies for doing the same job, so that it might have a slightly a different range in the values, because like the DNA microarray and RNA sequencing won't have the same range for the features in the transcriptomes. Again, as we can see, SWARM outperforms the individual nodes. In this case, we have taken around 12,000 samples to make it very sufficient that even individual nodes can perform better. So we can see that the DNA microarray, so which is known in the medical thing, so it is fairly better in identifying even the other type. But the RNA sequencing, which is new, it sometimes fails to identify if the data samples is coming in the other kind of the technology. But SWARM, it kind of outperforms. So it kind of proves we can handle multiple different kind of the input types which are coming into display. We also wanted to scale that. We did an experiment to try it out with the 6 node. And then again, we could see that SWARM outperforms the individual nodes in terms of its results. So we looked at here multiple parameters to show it, like accuracy, sensitivity, specificity parts. And then finally, just to show also in terms of the uneven distribution of the case and control, as well as uneven distribution of the total number of records, which is typically a more generic thing which you can see, same as what I showed with X-ray image kind of a thing. Again, we can see SWARM outperforms pretty much all the nodes. And clearly you could see the node 2, which has a 1:99 kind of a ratio. It does a pretty poor in terms of identifying the disease, because it doesn't have sufficient samples. Even same is true with the node 3, with having a very good kind of a sample ratio also, but when you look at SWARM, it kind of outperforms all of that. I think I kind of covered a couple of use cases to explain how it works. And just to summarize the value proposition, as we discussed, the models are trained in the edge, so the no data moves. It provides kind of a good, improves the efficiency in terms of the bandwidth and all, and the data movement and all. So we don't have to copy the data. Data stores in the edge, and the available compute on the edges which are used for doing the computation. And it provides the privacy preserved, as I said, the data doesn't leave, and then also the parameters are also merged at the edge. So there is no central coordinator kind of an aspect. And for a highly secure kind of an environment, we also support homomorphic encryption to share these the parameter values, so that even if somebody wants to hack it, they can't really look into the weights to do a reverse engineering to find the model. So we have clearly seen, so we have built that the entire thing on a blockchain, so we could enable the members to come participate. They can control the access permission where they want to participate and all. It also helps in terms of dynamic scale up, scale down of these nodes. And also we provide the auditing support using the blockchain in terms of what are all the activities which are happened in this entire learning process, what stages, who contributed, and all this kind of an aspect. So it also keeps track of the auditing, which helps in the collaborative environment. We have very clearly seen the benefits of the biased learnings in the previous examples. The monetization framework, as I talked, we provided it through the cryptocurrencies, which we haven't tried or implemented in the real deployments, but yeah, so we do have a framework built on blockchain which can be used. With that kind of a background, let's look at how it could be done. So on the technically, it's implemented as a software library, and it's completely containerized so that it can run with any container kind of an environment. We're showing it like the HP container platform on which we have tested and running it. Underneath, it could be any kind of a hardware. It could be a hardware on on-premises, hardware on the edge, hardware on a cloud, or a hybrid cloud, and those things. So it doesn't matter. It can support all those things. And based on, it uses a couple of the open source component which I've shown in terms of a machine learning framework. So we have tested it with Keras, TensorFlow. We're working with the PyTorch and those things. We support multiple of those machine learning frameworks. So it's not kind of tied into a particular framework. So we do support very different kind of frameworks. And also on a blockchain, we are using Ethereum today, but again, it's developed in such a way like if a customer has a preference or he's already using a different blockchain technologies to participate, again, it could be plugged in instead of an Ethereum blockchain kind of a component. And that entire library exposes a set of APIs to make it easy to integrate with the application models. So we know like the customers who have the data, who have built the model to look into like what they are trying to solve and those things. They can bring in their model, leverage swarm learning by consuming the APIs which are exposed to the swarm learning library. And let's see if we have your own model, how that could be converted into a swarm learning. Excuse me. Excuse me, apologies for that. So, as I said, the swarm learning software is provided as a container. So it's a pretty easy in terms of, these are Docker containers. You could install the Docker container using a Kubernetes or you could use the HP container platform kind of a thing. We are working on that integration to do and integrate. Then the aspect is the network need to be kind of configured with little bit parameter to participate in a blockchain, like the number of nodes or the port on which they participate and all those things. It's a typical configuration stuff. And also set up the data volumes for both the training data and then the test data. It could be coming through the pipe on the network, or it could be coming through the storage, and then that need to be set up. The key aspect, I think it's of the very interesting thing, is an integration. So we know the data scientists who are working on a different framework and building the model, we wanted to make their life very easy to integrate or convert that model into a swarm learning. So we try to make that very simple 4-step process. So it's first is importing that library to get that framework brought into that Jupyter notebook or whatever your favorite IDE on which you're using, and define a callback. So that is the key, or I would say the only API which is required to be integrated to convert an existing model into a swarm model. So as you can see, there are some parameters on this one. We're clearly seeing the RV interval, min, peers, and all those things. So these are some amount of tunable parameter. I will talk about that probably in a minute. Set up those things, set up the data which are used for training and then validation. So similarly, how you do it in your modern training, and then add this callback into a callback list. So I'm showing an example in a Keras here. If you are doing it on a native TensorFlow, it might be a little bit more, a few more lines of code. But in terms of Keras, it's just assigning it and then pass that callback into the model training loop. That's basically a generated thing here. It's as simple as that. Okay. And then you start training the model. So during the training, so typical of any of the machine learning thing where you do the hyperparameter tuning. With Swarm also, we have a bunch of parameters, so which some of them we saw in the parameters to the Swarm callback APIs. So we provide option to decide the number of nodes which need to participate in a merging. So look at if you have multiple nodes, some of them, let's say if they get dropped out or disconnected from a network or to handle scenario like that, or there might be some nodes which are laggards. That means like they may not have sufficient amount of data so that they are running slow kind of a thing. To handle all those things, we say what should be the minimum number of nodes and how it could be tuned to decide in terms of merging algorithm. It's a parameter. We would provide a parameter to decide the frequency of a merge. So if you reduce it too much, that means like we could merge with every batch. Increase it too much to do it only once. So that is two extremes. But most of the time, you may have to find a middle ground to look at optimizing between getting a good accuracy as well as how quickly you can finish the training. So there are a lot of parameters to tune that, and various different kind of a merge algorithms. So far, I just mentioned averaging kind of a thing to do a just merge, but some of them might need kind of a weighted merge or a different techniques. And again, we provide mechanism to use or provide various different weights into the nodes depending on the biases in the data and those things. So and then a few more things are there. So it's a bunch of tunable things there. So in a nutshell, it's a set of containers could be deployed and an easy API for integration. And to just show the real example, which I have shown earlier in terms of the identification of disease using X-ray. So we picked up the model from the Kaggle. So, and then I'm trying to show you a diff between that model and the Swarm model to show how simple it is. The NIH Keras.py, which is basically the model we picked up from Keras, and then we converted that into Swarm. As you can see, it's literally less than some 5-6 lines of code. So we just import the model, set up the callback parameter. I just try to show it could be done as a parameter list itself as initialization or do it earlier, and then pass it to callback. That's pretty much it. Okay. I think this is a good time probably to open up for the Q&A to see any questions, comments.
Thank you. Thank you, Prasad. We actually have a few questions already that has come in. So let me show them so that all of you can see them. Just hold on a second.
Would you read, or do I see them?
I will read it to you, but I've also now sent it out so everyone can see the question. And it's
Sure.
The first question is, in the swarm learning approach in which a node becomes the coordinator and merges all parameters, what are the computational requirements on each node in comparison to centralized model in federated learning?
Yeah, it's a great question. So let me just start with the centralized model. As I said, we get all the data into one single place and then try to train the model. It needs a very large amount of storage capacity as well as the compute capacity, because it needs to deal with large data. And then to ensure the computation can scale, even in a centralized approach, people implement a distributed training technology wherein which they partition the data and train it. But the requirement of the compute, I would say, it's very high in that space. The federated learning is similar to the swarm learning kind of a thing. So the models are getting trained on the edges with the local data. That means there is a less amount of data, but still it needs to train the same model. So the model which I've talked about in the examples are like a 10-layer neural network or 12-layer neural network with 8 million, 6 million kind of parameters. So it would need a good amount of compute capacity to train those model with the limited data. That's on the training part, which is, I would say, almost equal with the federated learning as well as the swarm learning kind of the technologies. The coordinator is not a compute heavy. It's basically doing an averaging of the weights and those things. And then the edge nodes, which is having the compute capacity for doing that local training, can easily do the role of the merging.
Okay, thank you very much. And then we have two questions related to the healthcare use cases that you were describing. And the first question is, what is the aggregation algorithm you used for the disease detection use case? Will federated average algorithm work okay if there is a high bias in the local data sets?
Great question. So we have used multiple of tunable parameter, which I mentioned about. Many cases where there is not a significant bias, a simple average kind of a technology, which is also the one which is used in federated averaging, it works very well. But if you have a large bias, so the example which I showed at the last, here we kind of tuned that one and then did a weighted averaging technology. So basically try to tune the weights accordingly, depending upon how the learning signals which are coming from individual nodes. Yeah, in this case, the weighted merge is used.
Okay, thank you very much. And the next question on that same topic is, did you compare the training times also for the healthcare use case?
Comparing the training time with respect to centralized or the individual nodes. The answer is no. We haven't really looked at more in terms of the comparing the training time, because as I said, in the centralized approach, what happens is you get all the data into one place, train the model, deploy it on the edge for doing inferencing. And typically to monitor that entire life cycle, what happens is we need to have a model performance monitors which are running on the edge. Try to identify any time we get a deviation in the performance from the training time to in production, and then identify the outliers and those kind of a thing, retrain the model, compare the performance of this old model and the new model, and deploy the better model and continue. So it's kind of a cycle. That's how it has to be done if we do it in the centralized approach. In our case, since in a swarm learning, it could also do both the training and the inferencing on the edge itself. It can help to do the continuous learning very easily. So the recommendation is you kind of train the model to get a desired performance level, deploy it, And then the new data which is coming, it could be inferred to immediately solve the thing, but at the same time, the data could be used for doing an incremental training on a swarm and keep on looking, is there an outlier, and then should that model need to be improved, kind of a thing. So there is a difference in terms of looking at end-to-end the latency or the time it's required to train the model. But yeah, no, we haven't really focused much on that side or tried to look at how long it takes to train.
Okay, thank you very much. And I also wanted to mention that on this call, we also have Sorin Sheeran, also from HPE. And I will promote you as one of our panelists. So everyone who's asking questions, feel free also to ask questions in general to HPE if you want to. Let me see. And then, of course, we have Peter Werdenhoff still on the call. So, and then we'll go to another question that we got. Could you share links to the studies or experiments that you presented?
The first one, which I talked about, the medical, the image-based one, yes, it is in a Kaggle. I can share the link later. The second one we are doing with the customers, I can't provide the data.
Thank you very much. And let's see, Sorin, would you want to just really quickly introduce yourself to the audience, just so they know who you are?
Yes, hi everybody. So my name is Sorin Keran. I'm currently driving the HPE AI strategy and solutions across the company, across the geos, across the various regions, and so on and so forth. And I think I've been involved for some time now with AI.SC, collaborating with Mats and the team on a couple of projects. Yeah, I prefer to take a step back because Prasad has the floor, and but I'm here to answer any possible questions around HPE and obviously AI as well if needed. Thank you.
Thank you very much, Sorin. So the next question we have is, can you please expand a bit on the technical readiness level of the swarm learning system just demonstrated?
Yeah, as I indicated, we have that library which is being tested in a multiple use cases. I picked up predominantly for the healthcare here. We have also done with a bunch of POCs, and the example which I mentioned, the disease identification and transcriptome, we are also doing the POC with the customer. So we are in a state where we could work with the customers in doing the POCs. And parallelly, we are also working on in terms of the commercialization aspect of it. Oh, yeah.
Sorry, go ahead. Excuse us.
No, I was just saying it is ready for the customer POCs and it could be tried out.
Thank you very much. And Mats Nordlund had a comment to that.
Yes, and for you here in Sweden who are also partners of AI Innovation of Sweden, these are the kind of projects we do here at the National Testbed for Data Factories. And since HPE is a partner as well, there are all sort of ways that you can go forward and explore ways to collaborate. And as I pointed out at the beginning here, there are also ways that you can apply for funding for such projects from Vinnova.
Thank you, Mats. And our next question is, how can we access the HP Swarm library to try it out?
Yeah, currently the mechanism is just reach out to your HPE, the sales or contact persons, or probably, sorry, do you want to comment on that? How could they reach out, and then how do we work with them?
Yeah, of course. So yeah, so from their perspective, it is there are two ways basically. The first path is to reach out from inside AI.SCE, in the sense that if you're reaching out to Mats and Eba, most likely they know they are going to come towards HPE, and we can actually link from there. And the second way, obviously, in the case of customers themselves, is they are convinced that they want to do that as well. The way we do this is that there is a local HPE person in rep in the country, and then basically that local HPE person knows how to get engaged all the HPE people in order to and teams in order to make sure that we are answering the request. So there are two ways. Now that we are here at AI.SCE, if you're a partner in AI.SCE and so on, it's easier to go. And Matt, I would let you comment on that as well. I think you just did. So we can go via AI.SCE and then they arrive at us. If you're not part of AI.SCE for some reason and you still want to try it out, obviously we can easily do that through directly via HPE. Both are viable. And we just need to understand, based on your requirements, would you need access to the system? Would you need to a system where we are, working on this? So we are actually working on an environment together with Prasad on simulating this, so people can actually try it out, right, with our guidance. So there are a lot of alternatives that we can play. It's just a matter of reaching out for now. Thank you.
And just to be clear there, this is Peter Voronov. So I am the local HP contact for all AI.SE related questions and inquiries. So please reach out.
Thank you, Peter. Yeah. So yeah, AI.SE for us, it's Peter from the HP side. I apologize. Thanks, Pete.
Thank you very much. And please feel free to contact me, Ebba Josefsson Lindqvist, and you find our information on AI.SE's website, contact information. And if you have any questions and want to get in touch with HPE through us, you are more than welcome to reach out, and we will, take care of all these requests and be happy to do projects, etc., that can merge and engage partners together. And we might have invited some potential partners, and if you aren't a partner already, of course, we would encourage you to become a partner as soon as possible. So we have another question. How can you guarantee that the trained swarm model does not contain information revealing individual data from any of the node data sources?
Yeah, as I indicated, none of the data leaves the sources. So the models are deployed and trained there, and only the weights which are sent. And these things are kind of recorded on a blockchain in terms of what goes out. And even the trained weights, which is transacted between the local node and the coordinator using the secure communication protocol using some encrypted links. And to the next level of security, we also provide encrypting that weight using homomorphic encryption and sending it to your coordinator kind of a thing. So there are multiple levels of security thing we support, and general I would say is like everything is kind of a blockchain audit thing to look at. And then they could also look at what kind of a data which is moving outside of data source.
Thank you. And then we have another question. Do you have any results or tests about how sensitive or stable is the swarm learning against data poisoning, model poisoning, or inference attacks?
Yeah, as let me answer the couple of things. The data poisoning, it typically happens with the biases which comes in here. That's one way of looking at poisoning the data. So as we could see in the biased environment with a couple of examples, it's able to take care of that to a decent level. And poisoning in terms of the weights and those things, the attack, as I mentioned, that the algorithm to do the merge is protected with blockchain smart contract. So the consortium or the network which agrees for a mechanism of doing that merging, they could agree upon that and then write it as a smart contract, and the smart contract goes into the distributed ledger, so it becomes a tamper-proof code or a legal the tamper-proof software contract, and the same contract gets executed. So it again provides the protection for that from the other attacks. So we kind of take care of both of that. And then so far our experiments is kind of proven the data biases works well, and then smart contract protects it. But we are kind of very much interested to collaborate or work with the customers and then maybe do some more experimentation or studies if they have in the mind to see what happens. So we have tried various different biases, but if it could be in a different settings or a different mind, yeah, we would like to kind of explore.
Okay, great. And just to elaborate on that a little bit further, we have a question on how do you deal with inference attacks, and you touched on it, but maybe you can elaborate just a bit more on. that specifically.
Sure. Can you just elaborate what you meant by inference? Did you say inference attacks? So I think I didn't get that question.
Yes. How do you deal with inference attacks?
Okay, so I'm kind of assuming here you're trying to look at it. Are you referring to
suggestion to what that might?
Are you looking at adversarial attacks or adversarial patches or adversarial neural networks? So which part of what do you mean by inference attacks in this case, just to specify a bit better?
And we had a question from the participants here. So whoever sent in that question, can you elaborate a little bit more on that? That was Daniel, I think. So if Daniel, if you want to just sort of type a little bit more, and we can come back to this question shortly. And
yes, and let us just take another question in the meantime. What is the maximum number of nodes that Swarm Learning framework can handle?
The framework is designed in such a way it can handle a significantly large number of network nodes. So it's in hundreds of thousands, but we haven't really tested at that scale. So design principles of the framework supports, as we said, we are kind of gone with the blockchain, and the blockchain supports thousands of known nodes in its implementation. But in the Swarm kind of situations, we haven't really tried up to that. So we have tried into a couple of tens so far. So I'd say 20, 30 kind of numbers in most of our experiments.
Okay, thank you very much. And then we have another question here. Do you consider the existence of adversaries in the network, I mean nodes that inject false information?
The way we try to protect that is by looking into the authorization at the time of members participating into a network. So we assume the participant of the network are the good citizens of that network. So they will be validated using the whatever the corporate standard in terms of the securities like LDAP, AD kind of an authentication framework there. But once they are part of a network, no, we don't do any special kind of the checks.
Okay, good. And now we have an explanation here from Daniel in the chat section. So for the question, how do you deal with the inference attacks? First part is to learn about individual data that goes into a model by doing structured inferencing. The other part is the ability to recreate the model for own purposes outside the network. If that helps you answer the question.
Oh, sure. As said, there are two ways it could happen. So one, the data movement, we have said it's kind of protected, the no data leaves, so it falls into that category. The second part is a very interesting part. So there are research which says if an attacker can look into weights repeatedly or the weight of the model, they can try to reconstruct the model or even try to reconstruct the data by looking into weights of the model. So there are two ways we would recommend handling that. One is these weights are merged by a various different nodes. So that's basically, it's not going into a same node every time. So that way the possible probability brings down the node seeing that weight repeatedly. And the other aspect, as I said, the weights could be encrypted using homomorphic encryption so that it's completely a crypto safe in terms of the content of that weight, and the merge will operate on the encrypted data. So it protects the weight so that even if an attacker comes and tries to get that, he wouldn't be able to kind of reconstitute that. But let me just say, so that's a feature which is still in the lab kind of a space, I would say. We haven't really tested or worked that with the customers, but the other things which are ready for the POCs.
Thank you. And we have 3 more questions pending, but I just wanted to ask you, Prasad, did you have any more of the presentation that you also wanted to go ahead with, or should we continue with these 3 questions?
I think we can continue with the question. I didn't have any further content on the presentation slides.
Good. I just wanted to make sure. Thank you. So we have one more question here. If code is not publicly available, how can security be audited before engaging with HPE?
Let me just probably ask, so do you want to kind of chime in and answer that?
All right, so I think Daniel asked that question at one point. So Daniel, you mean in this sense that you want to audit how we are looking at security within Swarm Learning before you're actually discussing with HPE, or because that can actually be exposed during our conversation, how do you actually handle and how do you audit it? So you want to do that before approaching HPE, or you want to do that before putting that into production or before installing that? So the code itself right now, which is, it's all patented and so on and so forth, we are not putting it in open source simply because we are evaluating right now, not only this, but a lot of other libraries. How do we bring them together and make them available for our customers? So no, the code is not in open source, but the discussion around security auditing and so on, we can actually have that at the HP level directly with you or with the customer and so on and so forth. So the discussion can be held. And then from the code, opening up the code, I think we are going to have some very nice 6 months when we are deciding now how to expose this to customers quickly and so on and so forth. And together with Prasad, we've been brainstorming on a couple of alternatives from R&D licenses, development licenses, and so on. So this is under discussion in the team, but we are more than open to talk about the security and auditing with you even before engaging properly on a POC and so on.
Thank you, Sorin. Our next question is, how is the swarm synchronized? Is there a fixed periodic schedule? Is it required that each node finish their work at the same time, or any late submission can join in next slot?
Great question. So I talked about the few aspects in the tunable parameters when I discussed. Okay, no, let me just say. So there are a couple of parameters which you provide. One is the epoch. It tells what is the time window on which each of the node need to come and merge. Okay, it could be set with some number, let's say X, and we have a mechanism inside the Swarm Learning to decide whether to increase that merge frequency or reduce the merge frequency depending upon how the model is converging. So we call it as an adaptive merge, kind of the parameter. So you can start with some frequency, and then the framework recommends how to tune that depending upon how the model is converging or diverging. That's one part of it. The second part, we also have the tunable parameter like min peers, which I talked about. It can be used to handle some of the node if they dropped out of a network, or probably if they want to add to a network later in those things. I'll come to that. If they're disconnected, maybe because of a network challenge or the system challenge and those things. So let's say if you have 10 participants, the network could be constituted to say as long as 6 participants contribute, it can merge and continue to a next cycle, and the other 4 can probably skip or join later, kind of a thing. So that's another tunable parameter which we provide. And now, as I said, it can dynamically scale while the network is running. Let's say if we start the network with 10 participants, and if we need to increase that to 15 participants, kind of a thing, or the new participant need to add like 11th or 12th, they can come and add. They will join the network, and they can also start their learning at that level where the network is already with, and they can continue with that. So again, that could be controlled through these two couple of tunable parameters. So that way, I would say like it's pretty flexible in terms of handling the dropouts, handling the laggards, and handling the new participants.
Thank you. Next question, how is communication between the participating nodes done? And what is required at each location to support this?
All the communications between the participating nodes are governed by blockchain. So blockchain smart contract and the blockchain network acts as a backbone of this entire swarm learning. So whenever the participant node finishes their, let's say their epoch, it will be triggered or communicated through the blockchain signals or the commands. And The weights, as I mentioned, it is communicated using the secure communication. Think of it SSL, HTTPS based channels for doing the communication of the weights. To run that software on an individual node, you just need to have that swarm learning containers. We said there's a couple of containers which comes as part of this whole framework package. So that's pretty much. So it doesn't need any other special software.
Thank you. And we had another question in the chat actually about blockchain and what that is contributing with. If you could actually elaborate a little bit more on that, and also in the sense of security, because we had an explanation also from Daniel about security. The question is about the standard to never roll your own crypto in the security of sensitive application. It is a good design pattern to have code publicly available to verify design choices. So this is probably relating to two different questions, but if you can elaborate a little bit more on the blockchain and what it's contributing with, please.
Sure. As I said, the blockchain, we could look at, it predominantly adds 3 or 4 different value propositions. So the first one, I'd say it gives a very robust decentralized network. So building a geographically distributed decentralized network is a complex piece of software. Blockchain framework provides it and then makes it resilient, and which is based on an open source momentum. And we have used the Ethereum open source component, which is quite popular in terms of the blockchain framework there. The second piece I mentioned, we use the smart contracts. It's a mechanism of implementing the legal contracts in a software by using a trusted manner and a tamper-proof manner. So we use that smart contract feature of a blockchain to elect the coordinator for doing the merge, as well as ensuring the merge algorithm is tamper-proof or executed in a trusted manner. The third key piece is predominantly using the crypto tokens kind of a functionality or a framework coming through the blockchain for providing the monetization supports. So that's the key thing. How do we use the blockchain to provide the value add? And in terms of a security, as I said, we kind of using a standard crypto algorithms or the security thing. We are not writing our own crypto algorithm or doing it. The secret sauce is how we are kind of built or integrated all of them together to make a framework which is easier for a collaborative or decentralized machine learning. So most of the component, including the network, the smart contract aspects, and the crypto algorithms used, all are well-defined open source kind of algorithms.
Thank you very much. Our next question is, have you tried swarm learning on both supervised and unsupervised learning situations? And do you have any conclusions from that? Great question.
That means like that, okay, we haven't really kind of tried the unsupervised one. So far it works with the supervised learning. We are kind of doing a bit of experimentation in terms of unsupervised learning, but I would say at this moment it's a research work, and we haven't completed that.
Okay, great, thank you. And our next question then is, have you any thoughts on hybrid solutions, like combining central training and the swarm, and what may be good use cases for this kind of arrangements?
Okay, it's a great question. I would say in terms of the technology, we have thought through it. As I said, the swarm, it supports multiple networks. So most of the thing what I talked about today is a mesh network topology for the swarm. We could also support hierarchical kind of a network or a tree network kind of a topology. That means, say for an example, in a country, we can have a centralized learning, and across countries in a global, it could do a swarm learning kind of a thing. The framework supports that technologically, but in terms of a use case and those things, that's where I would like to learn more from the customers or the partners in this group if you have a specific use case for such kind of a topology to do it, please reach out. We would be more interested to know that and see how can we support. But yeah, but the framework supports it.
Thank you. So another question. How are you deciding which node is going to aggregate the weights? Can we tune swarm learning to have a centralized node all the time?
Yes, it is possible. If you want to select and centralized coordinator always, it's possible to do that. And as I mentioned in the presentation, prepared presentation, we could implement a round robin fashion in that. We could also implement a mechanism, the node which finished its local training first, it can volunteer itself to say, I will do the merging for this round kind of a thing. So we have tested all the three, and we could we have a plugin in such a way we could, if we find a different mechanism, we could implement that. Because one thing we believe, it might also closely associated with an incentive mechanism, because the node doing that aggregation, it is giving an additional compute power for doing that aggregation. It can be accordingly incentivized in that network. So depending upon the cases, while deploying the solution, there are, so the ones which comes default out of the box with the framework, it could be tuned through the tunable parameter. But if you need to build a customized logic for that, we could work together to build that logic and then plug that logic into the framework.
Great, thanks. And then we have a question from Daniel. Do you store model weights on the blockchain?
No, we do not store the model weights on the blockchain.
Okay, good. Quick answer. And then our next question, do you support setups where inputs, features are different among the nodes? This is usually not relevant for image data, but can be the case for tabular data.
We no, today we expect the model has to be exactly same, and then so the number of feature has to be same. So the example when I talked about here with transcriptomes, but however within the feature, if they are done through the different kind of the technologies, we do support that, and we have a mechanism to support them through the pre-processing. We would recommend how to do those things. It can be taken through the pre-processing, but the number of features we expect it to be the same.
Great. So differential privacy is often discussed in connection with federated learning. Have you any experience using differential privacy to enhance security further?
No, we have not really went that. So as I said, there are multiple security models or a framework. We could look at differential privacy, homomorphic encryption, MPC, and those. So we have kind of explored more with the homomorphic encryption route. It provides, we believe, kind of like that, okay, it gives complete security aspect there. So we didn't go through the differential privacy because it may do a little bit of a trade-off in terms of an accuracy is what we believe in our research.
Very good, thanks. And now our last question. So please, if you have some more questions that you want to ask, please type them in. But here's one more question. Many times data is stored and fragmented in different ways across different locations. How can your solution manage this?
Yeah, so it's again using this example, it needs to be taken care through the pre-processing. So if you get the data and then run through the pre-processing and then pass it into the model inputs, it will take care. So just to elaborate a little bit on this particular study with transcriptomes, the people in healthcare, I think they would know better than that, better than me here. So I'm saying when we do a blood transcriptome, we get kind of the sequence of these the data which represents the various different genes and as a features, and each of those features will have the value which is a floating point value. And examples, particularly when we looked at these blood transcriptomes, some of the cases we have dealt with the 20,000 feature set all the way going up into 60,000 feature sets kind of thing. And now depending upon the technology which is used for generating this transcriptome, be it a DNA, or RNA sequencing kind of a thing, the way they put the value to the each of those features, it varies significantly, kind of a thing. So the floating point number or the value of the feature which I said. So as I showed in this example, we successfully kind of taken 3 different platforms or 3 different technology to do this transcriptome for the blood, and then showed it works. But the catch is all of those technology generated the same number of features what we are looking at. So that's predominantly the same number of genes on which we are looking at, but the way in which they have generated that would have been different. So that's kind of taken. So typical of doing any of the model pre-processing, those kind of a thing could be handled and then fed it into the Swarm network, and then it would work.
Thank you. We received some more questions, and one of them is, can we use the HPE Swarm Learning framework on resource-constrained edge devices like mobiles?
We have not tried on the mobile kind of a devices. We haven't really kind of targeting it into the consumer-centric kind of an applications. But however, let's say we are kind of looking more in the enterprise kind of a thing, and we tried on the edge devices. So HP has in our hardware portfolio, we have devices called edge devices, which predominantly could be actually work outside of a data center in the rugged environment, say maybe next to an oil field or next to a medical image processing systems in the hospitals, laboratories, and things like that. And we have tested the swarm learning on those edge devices.
So I wanted to add here that currently we are looking at as small as we can get on the HP portfolio, in the sense that we are looking at the smallest devices possible, which are in our edge.
Soren, I think at least for us, your picture is frozen and we can't hear you. So let's see if we can get the answer one more time from your side. There we go. Now you're back. Do you want to reply one more time to that? Because we couldn't hear you.
All right. Sorry. You're talking to me about, I guess, right?
Yes. Yes.
Oh, I apologize. Okay, sorry. So my audio went up and about. Okay. So what I wanted to add to Prasad's answer was that currently we are looking at obviously HP portfolio for now, and we are trying to run even on the smallest edge devices from our edge line offering. But as we are exploring the darkest and let's say not the darkest, the farthest edge possible, trunks of the car, poles of electricity, we have some partnership with some other companies that are looking at putting this on the manufacturing floor, on the smaller robots, and so on and so forth. We are exploring alternatives of, for example, either going on the edge device itself, or having various edge devices connecting to APIs on larger edge devices. And so there are a lot of things in plan for this, but it's just a matter of prioritizing for the team for now. But we are happy to discuss it.
Thank you very much, Soren. That was now we could hear you perfectly clear. So we have one more question, and I think we'll do that as our last question before we wrap up. And the question is, in cases where the size of data sets differ a lot between different sites, do you have a solution to run on different number of compute nodes in different locations? As in locations with more data needs, compute nodes in order to not slow down the process as a whole?
That's a great question. As I said, it could be looked at in multiple ways, and definitely. We could look at probably running them on the high-end kind of a system to accelerate with high-end GPU and those things. That's one way. Or the other way, as you said, yes, on the nodes which has a large amount of data, they could do a local distributed training. They could just simply use the distributed, I'm using TensorFlow here, it's like a distributed TensorFlow or a framework like a Horovod. Or swarm learning could also be used to do the local distributed training. In that case, all the nodes participating in that swarm learning would be coming from the same data center. And then we can have this hierarchical kind of a swarm network. Yeah, it really makes sense depending upon if there is a significant bias in the data distribution and the nodes which are having a large amount of data. Yes, definitely they can implement some of the distributed technology to train.
All right, thank you very much. That was a great Q&A session. And thank you everyone for adding your questions. We think this is a great way of really interacting together and getting the responses and understanding the webinar in a full and good way. And thank you, Prasad, very much for the presentation as well. And we have actually prepared a poll that we would like to run now, just to see the technical. This is for us here at AI Innovation of Sweden, to see what do you think of the level of the technical parts of these presentations, to see what is needed going forward for partners that have a deep knowledge or more of a general knowledge on these subjects. So I'm running the poll right now, and feel free to answer. We'll give it a couple of seconds to see the responses. So the question is, what do you think of the technical level of this webinar? Is it good, too high, or too low? And so far, over 50% of the attendees have answered. So we're quickly going up. And I think we'll stop it about there. And it seems like most of you think this was a good level on the technical side. Some thought it was a little bit too high, and some a bit too low. So I think we hit it pretty well on this one. That's great, and we'll keep this in mind for our next webinars, to see how we can, tailor make it for partners, to get the most out of our webinars together with our partners. And then I also want to remind you all again about the next episodes of this webinar series, the Data Factory series, that will be on the 25th of June, and we'll send out invitations. Feel free to share those invitations within your organizations to anyone who you think might be interested. And the first one will be at 9 o'clock with the Swiss Data Science Center, and we will have Google that same day, probably back to back, but we are setting the time for that today. So, and then I also want to remind you again about the open calls for Vinnova for the applications that Mats mentioned. Do you have anything to add, Mats, for this?
No, great start of this Data Factory series, and thank you very much to the colleagues at the HP, and also to everybody else who joined in on the audience. Great job.
And Prasad, Peter, or Soren, is there anything you would like to say, just lastly, before we wrap up?
I think thanks. It was a very good discussion. So it's a lot of good questions. I really liked it. Thanks for having us. Just a quick thing, Ebba, is it possible to kind of send that question? So I would like to probably have to look at that if it's possible.
I will look into that and send them to you.
Sure. Thank you.
So Ebba as well, I think that the session was recorded, so if we most likely partners within AI.SC will have access to the recording, I understand?
That's what we're planning to do. We will send it to you beforehand though, so you can just say okay.
Fantastic.
Most likely published on our website, because I think this is a topic where everyone who couldn't attend today would also like to get the chance to see if they can also see it. But we'll send it to you beforehand, so you can okay.
Thank you, Eva, and Matt, thank you very much for the collaboration, and we're looking forward to actually have more events like this, and happy to collaborate, and we are open to other questions offline, and thank you for the opportunity.
Thank you so much, and have a great continuance of your day, and we'll see you on the 25th.